Hi and welcome to Gaffer's Grinds. Welcome back. This is video 8 in our series on particles for the Junior Cert Science. Okay, so in these videos we take concepts, we break them into small pieces, we try and understand them, we break them down into questions. So that you try to eliminate all distractions. So if you have a phone, try and stick it in another room or turn it off. And if you have any other tabs open on your computer, close them now. Again, quick reminder, why is this important? Well, when we learn, we use our working memory, and any other distractions can basically clog up your working memory because it's quite small. So any distractions like notifications, messages, YouTube, music, sound is all going to put information into your working memory and get in the way of this stuff that we want you to actually learn. So that's the reason why it's really important that you do that. The most important thing that I always ask is that we're going to do some practice questions. Okay, so I'm going to give you some practice questions to do. And when I give you practice questions, it's really important that you do the questions. Okay, if you don't, you're probably not going to learn anything from watching these videos. So make sure that if I ask you to pause the video and do a task or some questions that you actually do. Okay, so this video is a quick reminder. This is video 8 in our particle series. There's not much point in jumping in here and just starting here if you haven't been watching the videos up to now. The other stuff leads into this, so you're not going to understand this as well if you jump in here. So it's important you go back and watch them in order. This is a really good place to learn about junior cert science particles, but it's important that you do them in order. So very quickly, we're going to be discussing the conservation of mass when we do physical changes. Okay, so conservation of mass. Well, before we do the conservation of mass, it's really important that we actually revise the concept of what mass actually is. So what is mass? Okay, so we know that if we take any particular substance, okay, and we take a substance and we ask, well, what's it made of? Well, we know at this stage that any substance is made of particles. So this could be a substance like these are the particle arrangement for a solid. So any solid substance, sodium chloride, chalk, wood, concrete, any substance is going to be made of particles. Now, if we were to take two boxes, so imagine we've got two boxes. This is box A. Okay, this is box A, and this is box B. Okay, why did that not make a box? Sorry. This is box B. Okay, box B. And in this box is some matter. Matter is just anything made of particles. So any substance made of particles we call matter. So we've got some matter in here. Now, if we've got some matter, how would we show it? Would we show it using some circles to show that there are particles in here? So A has particles. So I'm going to draw some particles now. B also has particles. So it's got a substance, which is made of particles. Both of these boxes have some matter in them. Particles. The question is, I'm asking, is which box has more particles? This should be easy peasy, but on 3, I want you to speak your answer to the screen. Which box, A or B, has more particles? 1, 2, 3. I'm hoping that you said box A has more particles, and therefore we can conclude that box A has more matter than box B. Now remember, particles, P, particles are really tiny, extremely tiny, really, really, really small. So when we have a lot of these particles together, it's not very helpful to start trying to, if I asked how many particles are in a substance, in a sample of a substance, it's not very helpful for us to start thinking about the numbers of particles, because the numbers get so big. We're talking billions and billions and billions of atoms in even a small amount of substance. So if you have even a teaspoon of water, there are so many billions of atoms in that those numbers just aren't helpful for us to deal with. So generally, if we want to find out how much matter is in something, how much particles we have, if we want to measure the particles, we often use something, a quantity. Remember, a quantity is anything that we can measure. We use a quantity called mass to do this. We use a quantity called mass. So mass, this is revision. What is mass? Mass is the amount of matter, an amount of particles in a substance or in an object. Okay, so that's what we're doing when we find the mass. We measure the amount of particles in a substance. Now, say if we took an object like box A here. So we took an object like box A. So drawn an object like box A with some particles in here. And we wanted to find out, well, how many particles are in here. A way we could do that is we could measure the mass of box A. We could stick it onto a piece of equipment called, we call this a mass balance. So this equipment to find mass is called a mass balance.
I'm just wondering whether this is a mass balance. The English becomes screen number, which is going to be used to find out how much mass is there. Now, let's just say we also take a mass balance and then how much substance speed is first of all, so we just call which mass balance which cell in which respect showing the higher medium mass. These examples so if we want this mass, let's say the mass of A is equal to 50 mass. And then we expect mass of A just after substance. Now, why is it 50 grams for A and 20 grams for B? Why are they different? Well, the reason why the number is bigger for A is
So that's a recap of mass. But what's important here is not what mass is, because we kind of already know that. But what's important is what happens to the mass when physical changes happen. Now, we have already seen some examples of physical changes. Physical changes are changes to substances where no new substance is formed. So for example, if I take water and I make water, but I draw it when it's a solid. So it's water that is less than 0 degrees. It is cooler than 0 degrees. So say it's water at -10 degrees C. We call water at -10 degrees C. What do we call this solid water? So on 3, speak your answer to the screen. 1, 2, 3. Hoping, we said we call it ice. Now say we take that ice and we add heat. Heat. Sorry. Write properly for me. Come on. So add heat. And we were to draw the particles again. Okay. What has happened to the particles? Well, what I would expect to see is the particles, some of the forces of attraction that were holding the particles together in a solid have now been overcome by the energy that's been put in. And the particles now are not kept in as neat, tidy rows. Now, I am actually going to count the particles here in this diagram on the left, on the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 particles here. Now, why is it important for me to count them? Well, it's important for me to count them because a really important thing is that if we had 9 particles to start with, so in this cube over here, there are 9 particles. So in this ice cube, there are 9 particles. When it melts and the particles move apart, it's really important that we understand that we don't destroy any of the atoms. Okay, so the atoms don't disappear and we don't make any new ones. So that's why I've intentionally made sure, I've done this by design, by the way, is I make sure that in the liquid water as a liquid, remember this was water as a solid, this is water as a liquid, and this might happen at, well, it melts at 0 degrees. So at 0 degrees C, it would start to melt. And then, yeah, so it's going to be water now. At 0 degrees C, it's liquid water, okay? And this was melting. Melting is an example of a physical change. It's a physical change. Melting is a physical change. And what does this mean? It means we don't make any new substance. We have just changed it physically. So all that's happened here is that some of the forces holding the particles together have had enough energy that the forces are overcome. And now the particles can move slightly further away from each other. Now they're still close. They're still pretty close, and they're still held reasonably tightly together. But they're not in this perfect regular arrangement anymore. So that's all we've done, is overcome and change the strength of some of the forces between the particles. We haven't destroyed any particles, we haven't added any particles. So what can we see, or what can we predict about the mass? If I had 50 grams of ice, if I had 50 grams of ice and I melted the water, what would the mass be at the end? So on 3, 1, 2, 3, I'm hoping that you realize that the mass would still be 50 grams. Why? Well, again, mass measures how many atoms there are, and we haven't changed the number of atoms. So technically, the mass shouldn't have changed. This is a really important law in chemistry. It's called the law of conservation of mass. The law of conservation of mass. Now, what is the law of conservation of mass? If we were to describe it in some words, it states that matter, which is what causes mass, remember, mass is a measurement of how much matter there is. So it states that matter, or / atoms, because matter is made of atoms, states that atoms cannot be created or destroyed. Cannot be created or destroyed, but they can be physically changed. So, example, they can go from a solid to a liquid, or they could go from a liquid to a gas. So they can be physically changed, but this does not change the amount of particles. So this is the law of conservation of mass, and it's a really important rule in chemistry. what I'm going to get you to do, guys, is I'm going to get you to take that down for me now. So pause the video and take down that definition of the law of conservation of mass. Okay, welcome back. You should be watching the video again now if you've taken down the law of conservation of mass. Okay, let's look at another physical change. So I'm just going to rub this out now, make some more space for myself here. Sorry. Okay. Let's say we have a beaker of water. And the beaker of water contains, this is water. And we have 50 grams of water. So when we put it on the mass balance and we measure how much water we have 50 grams. Now, let's say we take some salt. So this triangle represents a pile of salt. Salt is another substance which is obviously made of atoms. And of the salt, we have 10 grams. Now, if we take our salt and we put it into the water like that and we mix it, we do something called dissolving. Again, this is not a new concept for us. We've already seen dissolving. So we dissolve the salt in the water. So we take our 10 grams, we put it in the water, we mix it up, and it dissolves. Now it looks like it disappears, but we've already learned that it doesn't disappear. What happens is the particles of the salt get pulled apart and they mix with the water. We call this dissolving. The question is, what happens to the mass? So we started with 50 grams of water. We put 10 grams of salt in. So what's going to happen to the mass? Is it going to stay at 50? Like the water was originally? Or is it going to change? Is it going to reduce because the salt disappears? Is it going to increase because we've put salt in there? Is it going to, I'm not sure what's going to happen. I'm asking you. Okay, so on 3, I want you to speak to the screen. Tell the screen what you think is going to happen to the mass. Okay, I'm hoping that your idea here and what you think is going to happen is that because we had 50 grams of particles of water, if I was to draw these using black circles here, 50 grams, all these particles of water are in here and they make it be 50 grams. And we take our salt and we put our salt in, and now we're adding in these orange particles, which are the particles of the salt. When we put them in, they break apart from each other and they mix in with the water. But hopefully you understand that the salt particles are still there. They have not been destroyed. Yes, we can't see them anymore because they take a slightly different form, but they're still there. So technically, we have to add on the mass of the salt. So the total mass here would be 60 grams of, what do we call this type of mixture when we mix together salt and water? So salt is a solute, water is a solvent. What do we call the mixture when we mix them together? On 3, speak your answer to the screen. 1, 2, 3. I'm hoping that you said 60 grams of solution. The word solution is a mixture of a solute and a solvent. Okay, it's practice time. It's your time to do some practice questions now. Here they are. So what I want you to do is I want you to get your practice copy or wherever you're going to do your practice questions here. There are 9 questions. I want you to pause the video and try your best to answer the questions now. Okay, so you should only be watching the video now if you have paused the video and given your best attempt at writing these questions, writing the answers to these questions. As I always say, it's really important to try and answer in full sentences because it makes the quality of your answers much better. Okay, so the answers are coming up now. These are the answers. Okay, so pause your video and make any corrections that you need to. Okay, I'm not sure that you would have had any problems with them. I think they're pretty straightforward. The only one that you might have had trouble with was number 6, I think. Number 6 might have been slightly difficult. Okay, so Matt dissolves, I'm going to just talk about this one for a second. Matt dissolves 150 grams of water to form a solution of 177 grams. Sorry, Matt dissolves salt in 150 grams of water to form a solution of 177 grams. Calculate the mass of the salt. Look, you may have been able to do this straight away. If you were, you can probably, if you were able to get all of these right, you can probably finish up the video and you've done a good job. If not, this is the one I think you might have the most problem with. Maybe 6 and 8. So I'm just going to discuss them now. So 6. Well, if the solution is 177 grams, like I have here, the solution is 177 grams, and we started with 150 grams of water, well, then the rest, the extra, must have been the salt. So let's find out how much is the extra. So if we take 177 grams and take away 150, which was the water, then the extra is equal to 27 grams, and that must have been the salt. That's how you do it. So you take away 150 of the water from the total mass of the solution. That's the extra that was added in, which is the solute or the salt. So that's 27 grams. Number 8 was maybe a little bit tough as well. A student has 200 grams of water. They boil the water and trap the steam in a balloon, which weighs 5 grams. What will the mass of the balloon with all the steam in it be? Again, my answer here is the mass will be 205 grams. Why is that? Well, all the particles of the water that you started with are still there. There was 200 grams, and they haven't disappeared because you've trapped them all in the balloon. So they're all inside the balloon. But now we have a balloon that we didn't have at the start. We only had 200 grams of water at the start. Now we've added the mass of the balloon, because the balloon is also made of particles. And the mass of the balloon was 5 grams. So we have all the mass, we have all the particles of the water, and now we've added the particles of the balloon. So the 5 grams gets added to the 200 grams. I hope that you found this video useful. I hope that you were able to answer the questions and that you didn't find anything too difficult. If you did, you can always go back and watch that particular part of the video or the explanation again. Guys, if you find these videos useful, it'd be really helpful if you give the video a like. It just helps other students who might be struggling to find the video, okay? Because it improves our position in the search engine. If someone looks for the title of this video, they will find this video easier. And also, if you have any suggestions or any questions or requests what videos you'd like me to do after I'm finished the particles topic, if you just stick them down in the comments, and then I can think about what area to revise next with you guys, okay? So I hope you found this video useful. I'll see you in the next one.